Hello, welcome back to Learn Physics. In today's topic, we are discussing with the solved examples of the second chapter, that is electrostatics part 2. That is second chapter, electrostatic potential and this capacitance. That chapter solved example question we are going to discuss. Okay, so I think the last days MCQs and all are useful for you, and please go through the textbook thoroughly. Again and again I am telling the same thing. Please go through the textbook thoroughly, because around 20 marks are for one mark questions and all. So please study the textbook. Okay, it's very important. So here in page number 55, so first example question. Okay, calculate the potential at a point P due to a charge 4 into 10 to the power minus 7 coulomb located 9 centimeter away. So it is a direct question. So charge is given, Q equals charge Q 4 into 10 to the power minus 7 coulomb and located 9 centimeter away. So distance is 9 centimeter. So convert it into meters. We should find out the potential difference. What is the formula? 1 by 4 pi epsilon 0 Q by R. This is the formula. What is 1 by 4 pi epsilon 0? 9 into 10 to the power 9. Q is 4 into 10 to the power minus 7 divided by 9 into 10 to the power minus 2. Okay, so here while you are solving, you will get it as 2 minus 2. So it is plus 4 volt. Okay, so that is a direct question. Hence obtain the work done in bringing a charge 2 into 10 to the power minus 9 coulomb from infinity to that point P. Does the answer depend on the path along which the charge is brought? Okay, so here we should find out the work done in bringing a charge Q to this potential difference, this region. If we are bringing a charge from infinity to this point, what will be the work done? See, work done to bring a charge from infinity to a particular point is where V amount of potential is present, then W equals Q into V. Okay, what is the value of Q which is kept? 2 into 10 to the power minus 9. 2 into 10 to the power minus 9 into we got it as 4 into 10 to the power 4. So we will get it as 8 into 10 to the power minus 5 joule. Okay, what is this is the work done. Whether it is path dependent? No, it is not. It is depending only on the initial and final point. It is not path dependent. Okay, or path independent. It is path independent, we can say. Okay, clear? So the next one is in page number 58. Okay, so the question I will read first. Two charges 3 into 10 to the power minus 8 coulomb and minus 2 into 10 to the power minus 8 coulomb are located 15 centimeter apart. At what point on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. Okay, here what at infinity, see I am taking two charges. Two charges which are kept at a distance 15 centimeter apart. So I need to bring this at what point on the line joining two charges is the electric potential 0. For which point we will get an electric potential is equal to 0. For that what we can do, see I am considering the two charges. See here, one is at 3 into 10 to the power minus 8 coulomb and other is minus 2 into 10 to the power minus 8 coulomb. So, and these are at a distance 15 centimeter apart. So, where we should keep a charge where that's where we will be getting a potential of is equal to 0. So how we can find out this one? What is the potential difference, or we can calculate what is the difference where we will be getting a 0 potential. I am considering a point, see here, P at a distance x from the first charge. This is A and this is B. Okay, so I am considering a point P where I am expecting this potential difference is equal to 0. Okay, so here the net electric potential will be 1 by 4 pi epsilon 0 Q divided by R. This is the point, isn't it? So Q at P due to A, that is 1 by 4 pi epsilon 0 3 into 10 to the power minus 8 divided by x. Q, not Q, B at P due to B, 1 by 4 pi epsilon 0 minus 2 into 10 to the power minus 8 divided by, what is this distance? 15 minus x. Okay, so this is equal to, the net will be equal to 1 by 4 pi epsilon 0 is common, 10 to the power minus 8 also common. So 3 by x minus 2 by 15 minus x. So this is the net charge, net potential, that is equal to 0 at this point x, is right? So this will be equal to 0. So 3 by x minus 2 by 15 minus x is equal to 0. Therefore 3 by x equals 2 by 15 minus x. So here 45 equals 2x plus 3x. So here it is 5x. So x we are getting it as 9 centimeter. So at a distance of 9 centimeter we will be getting a point, this potential as equal to 0. Potential difference is equal to 0. Now here we considered this x is between A and B. So it's not compulsory x will be equal to, x will be between A and B itself, isn't it? If I am considering a point outside here, so how this situation will be changing? Okay, I am considering in that way. Okay, so this is at a distance of x. Then what will be this distance? X minus 15. So here what difference it will be getting? So 3 by, that's one x, correct. VB, potential at P, P dash I am considering, P dash due to B. 1 by 4 pi epsilon 0 minus 2 by into 10 to the power minus 8 divided by, what is this value? X minus 15. So what difference it will be obtaining? Instead of 3 by x, 3 by x minus 2 divided by, what we will get here instead of 15 minus x, x minus 15. This will be equal to 0. So we will get it as 3 by x equals 2 by x minus 15. So that is equal to 3x minus 45 equals 2x. So x is equal to 45 centimeter. So that is another. So these 2 points, so if it is inside means at 9 centimeter from A, or if it is outside means it will be at a distance 45 centimeter from A. Okay, clear? Next is diagrams are given. Show these diagrams show the field lines of a positive and negative charge point, negative point charge respectively. And according to depending on the diagram, some questions are asked. First I will draw the diagram and then we will see the rest of the questions. Okay. So this is the diagram, that is here it is positive charge and here 2 points P and Q. This is negative charge, 2 points, so it is coming towards. Okay, so this electric field lines, it is direction is towards, okay, from positive to negative charge, right? So it is A and this distance is, this point is B. Okay, give the signs of the potential difference Vp minus Vq and Vb minus Va. Potential difference we know, V is equal to 1 by 4 pi epsilon 0 Q by R. This is the formula, right? So as distance increases, what will happen? V will decrease. So first I am considering Vp minus Vq. So P is here and Q is here, which is having more distances for R. If R is more, V will be less. So V at Q is less. V at Q is less than V at P. Okay, so what will be Vp minus Vq, which is positive? Vp is positive, so this will be a positive value. Okay, the same way, tell me what will be Vb minus Va here? Distance is more, so Vb is positive, Vb is distance is more, Vb is less than Va. So, but we will be getting a tendency, see here, same like here we can write down Vb minus Va as positive, right? But what is this? This is a negative charge. That means Vb will be less negative. This is more negative. So we are subtracting from a higher value to smaller value, isn't it? Suppose if it is less negative, minus 8, here it is minus 10, means what will be the value? Minus 8 minus 10. So we will get a positive value, right? So since Vb is less and here it is negative charge, so we will be getting Vb minus Va as positive value only. Okay, clear? So this one you should understand here. Okay, first part, that is Vb, Va minus Vb, Vp minus Vq is easy. But here you should understand this is negative sign. So Vb is less than Va means Vb is less negative than Va. So less negative means it is a positive quantity, right? So it is more, value is more. So Vb minus Va, we will get it as positive value. Clear? So the next is, give the sign of the potential energy difference of a small negative charge placed between the points Q and P and A and B. So between Q and P, if I am keeping a negative charge, and A and B, if I am keeping a negative charge, what will happen? See, this will be positive and negative, it will be attracting towards it. Okay, so if it is attracting towards it, what is the meaning? Potential will always move from higher potential region to lower potential region. So which is more? Potential at Q is more than potential at P, isn't it? So that is why it is moving towards this one. So here there's give the sign of potential energy difference of a small negative charge placed between Q and P. So it is, which is Q to P only, it is moving, right? So it will be a positive value. Okay, so here between A and B, which will be positive? So here it is repulsion. So Va minus Va is greater than Vb. So it will be a positive if we are considering the potential energy difference between A and B. While I am considering Va minus Vb will be positive value. Here it is a positive value. If I am keeping Vq between potential difference between Q and P, Vq minus Vp will always be also be a positive value. The reason is the negative charge will be moving towards the positive charge. So from higher potential region to lower potential region. So Vq minus Vp, while I am considering, it will be a positive value. The same way here, negative to negative repulsion. So Va minus Vb will always be a negative value. Okay, potential energy difference. Okay, QV. Next is, give the sign of work done by the field in moving a small positive charge from Q to P. And the next one, give the sign of work done by the external agency in moving a small negative charge from B to A. So here we should find out the work done by the field in moving a small positive charge from Q to P. I want to move a positive charge from Q to P. Okay, so actually the electric field will be moving outside, right? So same kind of charges means it will be repulsion. We should do against it because it is repulsion. We are trying to move it towards. So it will be, work will be done by the external agency. External agency should do work because actual movement is away from this. So against the actual movement, if we are doing if we want to move it, what we should do? We should do some extra work by the external agency. External agency should do work. That means work done will be, if work done by the external agency, then work done will be negative over here. Okay, positive repulsion, so we should do the against it. So in the same way, give the sign of work done by the external agency in moving a small negative charge from B to A. See, from B to A, from here to here, I need to negative charge. Okay, so work done will be negative. By the external agency means we should do it positive. So here work done will be positive because negative work done. Negative work done because this also attraction only. Negative to negative repulsion. Repulsion means negative value. Negative and negative. So we will minus QB. It is negative value. So total work done will get it as positive value. Here it is QV while I am considering Q into this one. What is that? Plus Q into V. So we will get a negative value. Here minus Q into V. So we will get a positive value as the work done by the external agency. Okay, clear? So here, but instead of that, if negative charge is moving away from it, means it will be a negative only, and this will exist as positive only. So the actual work done by formula, what we are getting is just opposite to that sign will be the work done by the external agency. Okay, clear? So the next is from page number 63. 4 charges are arranged at the corners of a square ABCD of side D. Find the work required to put together this arrangement. Okay, a charge, so second part, a charge Q0 is brought to the center E of the square, the 4 charges being held fixed at its corners. How much extra work is needed to do this? So diagram is given, a square like this, and here charge, this is A, B, C and D, here plus Q, minus Q, plus Q, and this is minus Q, and here this is the second part, Q0 and E. Okay, in first part, find the work required to put together this arrangement. What is the total work done? What is this? It should exist as the square. For that, how much work we should do? So how we can find out? 1 by 4 pi epsilon 0 Q1 Q2 by R. See, first AB, then BC, then CD, DA. And this distance also should exist the same, right? For that, 1 by 4 pi epsilon 0, first AB I am considering, Q into minus Q, divided by, what is the distance? D is the distance. Then plus, this is 1 by 4 pi epsilon 0, Q into minus Q, divided by D. Next, this one, minus Q, plus Q, minus Q, plus Q into minus Q, divided by D, plus minus Q into plus Q divided by D. Okay, then along with that, what is this distance? This one and this one, these distance also we should consider. So first considering AC, this is D and D. What is this? Pythagoras theorem. Root 2d square. So we will get it as root 2d, and this also we will get it as root 2d. So here q square divided by root 2 into d, and q square divided by root 2 into d. So we will get it as 1 by 4 pi epsilon 0 minus q square divided by d. How many are there? 4. Plus 1 by 4 pi epsilon 0 to q square divided by root 2d. So here taking 1 by q square common and 4 pi epsilon 0 d also common. Here minus 4 plus 2 by root 2. Root 2 we can take, and rest everything is correct. So this is the work done. Okay, this is how we will be finding out these two AB, BC, CD, AD to make this arrangement proper, and AC distance should be proper, and this one. So what is the work done? We found out this, and here the second part. A charge Q0 is brought to the center E of the square, the four charges being held fixed at its corner. How much extra work is needed to do this? Okay, so to say Q0 is kept at the corner, for that how much extra work we should do? So this much of work is there. Along with that, if Q is there, how much of extra work will be done? So here extra work equals, what will be the extra work done? Work done will be equal to Q into V. So what is Q? V, how we can, Q is Q0. What is the potential at this point due to the all other charges? 1 by 4 pi epsilon 0 Q by R. Right? So 1 by 4 pi epsilon 0 Q by R. So this distance, this distance, this distance, this distance, all those distances will be same. Right? What will be the value? It is equally dividing. So root 2 by D, root 2 D by 2. That will be the whole value, right? So 1 by root 2 D divided by 2 into, what is this value? Q. Total charge. Here it is minus Q and plus Q, then again minus Q. Plus Q minus Q and plus Q minus Q will cancel, so we will be getting as 0. So externally, so internally to keep a charge, we no need to do any external work. External work is not required over here, then all the charges are getting cancelled out. Okay, so extra work done will be equal to 0 in this case. So I hope it is clear for you, and only 3 questions we did, 3 or 4 questions we did, but the question which I did just before this, it is important question only. Okay, so and one question I will be giving it as a homework for you, and that is 2016 question paper. From 2016 question paper I am giving that to you. And if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.